Welcome, and thank you for joining Collect Anything with Webhook Beats Source Defined Parser. This is a presentation as a part of this year's Rhythm World Security Conference, and I'm glad that you joined in. So this presentation is all about the Open Collector's Webhook Beat and a community-released augmentation, the Source Defined Parser. By using this augmentation, I'll be able to showcase how you can collect just about anything with this resource. As part of this presentation, we're going to start out at a high level on the Open Collector's Webhook Beat, how log messages are processed through the system, and tail that overview by getting a bit more technical on a dive on how Open Collector's augmentation and the Source Defined Parser works. We'll have two demos in this presentation, covering the installation of the Source Defined Parser augmentation and an example use case where I'll be taking in data that's likely never been ingested in a sim before, data that reflects endangered species on our planet, into Logarithm using the Source Defined Parser. Lastly, we're going to be closing out with some references and call-outs to additional resources to help you be able to explore and leverage this resource for your organization. Before we get started in Open Collector goodness, I want to cover a little bit about myself. So my name is Eric Hart. I'm a Senior Technical Account Manager here at Logarithm. I've been here for just over 2 years now, started out as the first TAM in early 2020, and helped create and launch the TAM program. So the TAM program is a service now offered by Logarithm worldwide as a subscription service, and our goal is to align the prioritization and guide implementation for your investment in Logarithm's technical offerings. We work as your technical advisor, lead exercises that build effective skill sets, and operate as your voice and advocate within Logarithm to ensure any roadblocks we face are cleared as efficiently as possible. Now, this presentation is actually a representation of the outcome of some of the result of me working with the accounts that I manage, where we had the focus and goal of collecting logs from various automation processes that the organization was leveraging, from access and identity management, asset management, and incorporating in some of our SOAR workflows to produce logs that could be collected as well for monitoring. Do want to highlight that this is a recorded session, but I will be active inside the chat, so please feel free to raise any questions into the chat as this presentation is playing. I'll be able to answer questions directly as the presentation is going mid-course, so please don't hold back. Before we get started, I do want to pose a question to the chat room, and that's how many folks today are leveraging the Webhook Beat today? And what are some of the use cases where you've been applying the Webhook Beat for Open Collector? So let's start out with an intro of an Open Collector overview, and we're going to go specifically on the Webhook Beat since that's the resource that we're going to be working with this augmentation. So what is the Open Collector? To summarize it, the Open Collector is a series of containers that typically run from Docker. And these containers work collectively together to facilitate the collection of logs through various different sources. And those beats that collect the logs, whether they're submitted to the beat or they reach out to retrieve the logs, are ultimately passed to a container that is the Open Collector. And the Open Collector container is the main container that's responsible for transforming what's typically in JSON over to conventional syslog before sending forward over to the Logarithm System Monitor agent. So we're going to be going a little bit progressive on our slides to showcase what this looks like. So if we look at this diagram, we'll see that the 22 SSH, that's really our management or admin interface into the operating system that's running our Open Collector. On the right-hand side, we can see the Open Collector metrics browser. So this is a means that you can view the metrics app or the metrics container. That'll give some meaningful data points related to the actual Open Collector container and how it's operating. And we'll have references to that metrics app as a part of our demo segment. For the remainder of this talk, we're going to be focusing in on two parts of this diagram. We're going to be going into the Webhook Beat and the Open Collector. So we kind of focus down of what we're looking at here, and we're going to step through the workflow of what this really looks like when a log message is brought into the Open Collector webhook beat. So when a log message is first brought in from a log originator, which can be any type of service for the webhook beat, because this is a listening beat, so we can send in HTTPS messages, and from there they're going to work down this pipeline of receiving the log message inside that HTTP optionally encrypted listening service, and we're going to inspect that message inside this container, and if we see the conformed JSON data structure, we're going to then submit that over to the Open Collector for the Open Collector to perform its role. So it's going to, once passed over to the Open Collector now running in a separate container, it's going to evaluate that JSON data, and it's already going to start aligning some data translations based on the source. So we can tell that the Open Collector will know that, hey, this came from my webhook beat, so I'm going to tag this message and say this is a webhook beat log. From there, it's going to go into that stage 5, that logarithm JQ parsing, and this is really going to be the logarithm supported parsing. And we'll see the last piece, the 6, is optionally we can implement a custom, or another way to phrase it is a customer-driven JQ parsing. And once all of these steps are completed, the log is effectively sent out of the Open Collector container and forward over to our logarithm agent. Now, the Source Defined Parser is an augmentation for the webhook beat, but actually the augmentation resides in the pipeline of the Open Collector. So we're going to be still moving forward, building off of that same piece, but we're now going to be focusing specifically on that custom or customer-driven JQ parsing, where this is an augmentation that's pre-built, so you don't have to manually modify anything as far as creating or establishing the source-defined parser. It's a single binary file that you'll be able to import, and I'll showcase that when we get a little bit further on. And with this implemented, any message that goes through the webhook beat processing engine is going to ask one question up front. It's going to say, is this key value present? And that key is the letters WHSDP for webhook source defined parser. And if this key is present, it could be set to the Boolean value of true, or it could just be a string of any number of characters. So long as it's there and present, then it's going to want to process using the SDP's augmentation. But if that key is not present, then we're making no changes, and the log is sent forward over to the logarithm collection pipeline. But let's say the key is present. So in the case that that key is present, what this augmentation is going to do is it's actually going to look at the JSON data fields that are coming inbound through the pipeline of the message that was submitted, and where a logarithm metadata field, as we commonly know it, from the regex perspective, if you've ever done like the regex MPE rule building, we have certain regex metadata tags that relate to inside the logarithm deployment's metadata fields. So as we see the logarithm metadata fields based on our MPE's nomenclature, we're going to directly pass those forward into the output to be parsed by logarithm. And this ties back to the name, Source Defined Parser. So if we submit the data to the webhook beat with the data already in the metadata fields that we want, then that data is going to be presented in logarithm and parsed through the AIE, be searchable, and be usable without having to do any types of changes inside the Open Collector, and without having to do any types of changes inside your logarithm sim deployment outside of your conventional log source management. Now, you would likely need to create some sub-rules to assign common events, but outside of the assignment creation and assignment of common events for the custom log source that you're onboarding, you won't have to do any type of custom regex, and you won't have to really do any type of parsing changes. If you don't like where a data field is presented, you can change the metadata that you assign the data to in the source before you submit it, and it will be reflected in your logs from there forward processing wise. So let's look at an overview. So based on everything covered so far, the pros going for the Source Defined Parser augmentation is that it's very simple to install. We'll cover that in just a moment with the demonstration. The second benefit is that this augmentation can be applied to multiple unique log sources. The Source Defined Parser is not limited or created for any one specific log source, but it's actually a pipeline that's put in place for all webhook logs that are operating through the webhook beat. So based on this and the use of that key value, the WHSDP, we're able to ensure that only the logs that we want to run through this augmentation are ran through this augmentation, and that those that are, say, perhaps a logarithm supported log source that's operating through your webhook beat alongside having this augmentation installed will not be impacted. So the benefit of number 2 really leads to points 3 and 4. You won't have to create additional OC pipelines. So you can use one created open collector beat that can receive logs from multiple disparate sources. You can fan them out into multiple open collector webhook beat listeners if you so chose, but given the flexibility, you have the option. And for it, it prevents the need to create that custom regex. So you spend less time creating custom augmentations in open collector, and you spend less time creating custom regex to parse that log source that you may be collecting with this method. From the cons perspective, you can only leverage the Source Defined Parser if you're in control of the data. That's kind of, as the name implies, Source Defined Parser. It means that we have to be able to position the data that we want in a logarithm metadata field before we submit it to the open collector. This means that we likely cannot use this with a log source directly from a vendor or a technology to the open collector, but that you need some type of intermediary process, like a script, to be able to take the data from a file, from an API, basically from any type of source, and to controllably submit that into the open collector and have this augmentation applied. The second con is that this does require that your originator that's submitting data to be able to reach and access the open collector to submit the data. This can be a benefit, but it also can be a limitation. Maybe you want to collect data from a DMZ and you want to submit it into the open collector. Unless those two can feasibly talk to one another, then you won't be able to leverage this method. So just make sure that you align that the location where you're originating the data to submit to the open collector can reach the open collector. And then the third con, reaching a little bit on this one, but it's not installed by default. It's a nice kind of a quality of life enhancement that gives you the flexibility. Maybe you just want to submit in data as a means to test some AIE rules similar to logarithm echo, but where you're working with, say, JSON structured data, or you want to just create your own payloads of data and submit them in, then this could be an ideal solution, but it will not be there by default. You will have to manually install it. So let's take a look at what the data looks like prior to submitting, or when submitting this to an open collector without the Source Defined Parser. So starting off in the upper left-hand side, we're looking at that transform phase. So this is data that's already gone from your source. It's been submitted into the webhook beat, and now it's in the open collector where it's going through its parsing lifecycle. So as the data comes in, we see we have two fields, login with Eric H as the value, and action with logout as the value. And we can see the first output from the open collector is it adds in that beat name. Hey, this is a webhook beat. And it leaves the other two data elements the same. Now we come into the augmentation phase, assuming that we have the webhook beat Source Defined Parser installed. Note we don't have our WHSDP element. If we had that installed, we would see that present probably either inside this data set right here would be our element. But without it, the data remains the same, and we see augmented is set to true. This is going to be present, the augmented to true is going to be present in your logs anytime you have an augment set in on a specific beat. Now what this looks like when it passes through that syslog log message that goes onto that system honor agent, you can see the parsed out messages. So we can see the beat name is webhook beat. You can see augmented is set to true. And then the remainder, everything is unparsed because it's in the original message. So let's take this same example, and instead we add in that key, the WH SDP, and we set it to true. And that first transform phase, everything basically remains the same. We add in that new webhook beat, and from there, when we get into the augmentation phase, we see WH SDP is true. In the output, it's going to look similar, but the augmentation now operates off of those fields, the login and the action. Because WH SDP is set to true, what this ends up doing is creating an output to the syslog where login now is matched to the login metadata field and action is mapped to the action metadata field. So those are really the elements showcased in the data on how this is applied. So enough about looking at what this looks like when it plays through. I want to go through and just kind of showcase how simple it is to install the Source Defined Parser before we get into an actual demo of the Source Defined Parser. So for our demo, this is working in the TAM lab space here, and I have the webhook file downloaded to my open collector. That is this webhook_SDP. And this command, which is inside the documentations of the Source Defined Parser, provides this command, but by catting the webhook_SDP pipe and leading that into the LRCTL OC pipe augment import, we're able to fully import that pipeline. And with that import successful, there's really only two steps that we would want to ensure that this pipeline was applied, is by restarting the metrics beat, and that's going to help us restart all of our counters to have a clean slate. That's going to help us identify if we have any type of pipeline errors. And then the second piece, once the metrics beat has been restarted, is to actually restart the open collector. Because as the earlier part of the presentation covered, while the webhook beat is responsible for collecting the logs, it's really the open collector container that's responsible for transforming the logs. And just as simple as that, the open collector has been updated, and we can verify this by running an LRCTL status, and we'll observe really the uptime, and that's going to be for the open_collector, where we can see its uptime is 8 seconds, and metrics has been up for 32 seconds. The thing to look for here is if there was an issue, you would generally find that the container would be on a constant restart, so that uptime would show 1 second or 2 seconds, and it would also have a parentheses, restarted or restarting. So you would be able to visually see that there was an issue with the install. So with our demo, we're going to work off of a CSV source. I've worked with many customers related to CSV data. While we can collect CSV data using our system honor agent, there may be times where you want to not go through like the flat file management of CSV. Maybe we don't have our system honor agent on that host, or just the environmentals around it, or we just want to explore and play with the Source Defined Parser. This is just a great way to showcase the versatility of how the Source Defined Parser can be applied. So here we're looking at the process flow. On the left-hand side, we have our data provider, which is just going to be that flat file in CSV format. And our first step is going to be, we're going to read the data. Our second step is we're really going to map the data to the logarithm metadata fields based on the CSV's headers. And then lastly, we're going to submit that data into our open collector, which is the destination. And for this demo, we're going to be leveraging a PowerShell script to accomplish steps 1, 2, and 3 to working with the data provider and getting it to our open collector. So here's our CSV file, Now I'm going to do some quick edits to it to make it a little bit more visual for us. This would be the exercise of looking at this file and really looking at the columns and where would I want to position some of these columns into logarithm metadata fields. So I'm just going to do some pretty quick rough assignments. Again, this is data related to endangered species. So not really aligning to policies or user agents. We're really just going to take these values and then in our visual dashboarding apply some custom labels to make them more meaningful in our web console. But here you can see I stepped through those first 5 fields and really notate down what metadata field do I want this data presented in. So I move a little bit further down and I identify some additional fields where I'm going to place them in additional metadata fields. So here we can say I take the scientific name and I'm going to assign that to the login, where the taxonomy authority I'm going to put into the command metadata field. Once we have the mappings defined on where we want to present this data, we can move into the actual PowerShell script, and this resource is available as a part of this presentation. But here in our PowerShell, we define our data source, we define our data destination. We're going to define our fully qualified beat name, and this is a means that we can have that multiple log sources through one OpenCollector webhook beat. And on line 13, we map the data to the logarithm metadata. And all I'm really doing to accomplish that is I'm assigning my own headers while I bring that data in. Now on line 17, you'll note I have enable SDP. This is where we're adding in, effectively, a new column to our spreadsheet inside the PowerShell code. So I didn't want to modify my CSV, but instead I just wanted to add this property into each record that I'm iterating through from my CSV content. So for basically each line of my CSV, I'm going to make sure that it has my enable SDP. I'm going to add a timestamp on line 20. On line 23, I'm going to apply that fully qualified beat name, but ultimately on line 26 is where we submit the data. And I don't call out line 20 as a defined step because your source likely will have a timestamp. I happen to be working with a spreadsheet that doesn't have any type of field that represents time. And then the fully qualified beat name is an optional step. It's kind of a more advanced step. But definitely know that you can create your own fully qualified beat name to be leveraged in log source virtualization that you could then apply further downstream. We're going to execute the script. And while this is 27 lines, this is with comments. I think ultimately this is 9 lines of PowerShell code, 9 to 10 lines, where we're taking that CSV and submitting this into logarithm. And while this is running, we're going to go and move into the metrics container. We're going to view the Grafana dashboards related to the OpenCollector, and we're going to observe the messages coming into and verifying that our webhook beat is appropriately receiving logs. So here we can see that graph, and we see it across that top bar. We see the input MPS on the upper left-hand corner. We see that pipeline MPS in the middle showing us that that's the webhook beat that's receiving those messages. And on the right-hand side, we're sending those out to our logarithm system monitor agent. And note that we don't have any type of bar graph indicating that there are pipeline errors. So everything is processing through cleanly with no types of issues. So let's take a look at what this looks like inside the logarithm deployment. So I found my log source. I just put in CSV in my log source name. And we happen to have one CSV log source in here. So with this, I'm just going to do a tail of this log source since it's actively collecting. And we can see those log messages are rolling into the deployment. And this is no regex applied. It just has that Source Defined Parser augmentation submitted, where we augmented those column names to reflect logarithm metadata fields. And here we can see the results inside our collection process. pretty interesting stuff. I mean, I never thought to collect endangered species with a sim, but it just shows some versatility of how we can apply this type of collection method. Now, here we can see just the total volume. I think out of this data set, there was roughly 10,000 entries in that spreadsheet, so we really submitted in 10,000 logs. Didn't go for any type of efficiency here. We certainly could post messages faster, but here I was just submitting each log as one single line. You could group them up and achieve even higher throughput capabilities using this type of method. I am going to do one more replay of this same scenario, but what I've done now is I've turned off that magic key. I'm waiting for the log messages here to fully taper out because I don't want to play a second set of logs while we're still ingesting those with the key enabled. But by turning off the presence of that WHSDP value, now we're submitting the same data with all of the same metadata fields and the same structure that would work through our augmentation, but it doesn't have that one key value, the WHSDP. And as we start observing this data coming through, we're again going to retail our log source to view this data. But just note, we still have no type of pipeline errors, and we do observe that our MPS did come back up into the ingested level. So now we can view the logs that are coming into our console. So hopefully this gives a good visual related to what the Source Defined Parser is accomplishing. I know there's a lot of pieces to this chain, but ultimately with the Source Defined Parser in, part of the beauty of this is that you don't really need to know the full underpinnings of how it is accomplishing what it is, but it is good to understand how it is accomplishing what it is doing. We can note that in the raw log, we do see the actual log values presented inside the raw log, inside the original log message. We just ultimately, we don't pass those forward into logarithms metadata fields. So, let's take a look at what this data looks like inside the logarithm console. So I'm going to load up the lab environment here, and I'm going to run a new investigation. And let's see, I have a saved search here where I'm looking at my webhook beat. These were ran in the past hour, so I'm going to run my search. This is an older one here. I'm going to clear this guy out. All right, so we have some results coming in. So let's go ahead and load up to take a look at the logs that we were able to bring in. Now I did happen to create a special dashboard here just for our use case. And as we can see the species by their common name, their family name, what the species is, its species category, what the kingdom is. So it looks like we can choose from an animal-based or plant-based, and I can't pronounce some of these. Apologies, I don't work in that field. But let's take a look. So we can see that there's a fairy shrimp. So if we do a drill down on the fairy shrimp, we can see the 4 different species for the common name of the fairy shrimp. So that's very interesting. You'll never know what you could find. Looks like the most popular, or at least the most referenced common name, is the Polynesian tree snail. Who would have thought that this would be such a popular type of snail that is endangered, which is a little interesting. So to the live audience that's participating, how would you use the Source Defined Parser? What type of information would you collect into Logarithm? Would you bring in like stock data to look at some stock portfolios, or would you put it towards something more security focused? Maybe some internal tools, or maybe you have some custom smart responses where you can have your smart responses as a part of their operations submit in logs to your Open Collector with the Source Defined Parser, so that way you can have that visibility of your smart responses as they're running. That would be pretty amazing. So looking forward to seeing what the community can do when applying this, and see what else can be kind of produced as an additional kind of level up or next level of this type of capability. With that said, I do want to provide some additional resources. So the main one is the information related to this augmentation is posted on community under the Open Collector beats with the title Webhook Beat Source Defined Parser. This presentation brings with it all of the content that you saw here today. So the CSV example, along with that CSV file, so you should be able to, with an Open Collector set up and configured, run that shell script and be able to observe in your environment the same data that we brought in as part of this talk. The API example that I referenced is in that as well, and the files for the Source Defined Parser are on the subscription services GitHub repository as well. Not specifically in the Rhythm World content, but on its own for Open Collector, as we're consolidating some resources related to the Open Collector from our subscription services. And then lastly, I do want to make sure that I give reference to the Open Collector's augmentation documentation. So just in case that you want to use the Source Defined Parser as a stepping stone into creating your own augmentations or parsers, then you can apply this documentation really to help you augment, change, and create your own augmentation for Open Collector. So with that Source Defined Parser, I do provide the access to all of the non-binary files, so you can update it, change it, make it your own. If you're interested in learning more, I do recommend the talk Collecting from the Cloud and More from Jay Calderman and Jesse Kaufman. A little bit more specific to Open Collector from a higher level, but ties into a lot of the same type of content, so should be very related to the content that you observe from this talk. Do recommend logging and threat detection in AWS. Logging strategies for the cloud are always challenging and diverse, or can be. Each cloud provider can have its own recommended methods of collecting. So anywhere where we can get direct examples for threat detection in a specific cloud environment, I do recommend digging into that. And then lastly, on October 14th, starting at 8:30 a.m. Mountain Time, we'll be hosting the Log Wars Capture the Flag event. This will be, I believe, the fourth year of the Log Wars CTF. So really hoping some folks tune into that. You can watch and observe, or you can participate and play along. I know last year we held contests for single individuals as well as for teams. So please, if you're interested, tune in to the Log Wars CTF and have a good time. It's a great way to learn logarithm. And with that concludes Collect Anything with the Source Defined Parser.